real numbers, which is the decimal expansion of rational numbers. Let's memorize what is rational numbers. Rational number is a number which can be expressed in the form of P by Q, where Q naught equal to 0. Any number x which can be expressed in the form of P by Q, where Q naught equal to 0. This is a rational number. Now, how we will find the decimal expansion of this rational number? What is the method to find the decimal expansion of this rational number? To find the decimal expansion, we just need to divide the numerator by denominator. Here, the numerator is P. P divided by Q will give you the decimal expansion of that rational number. Now, by dividing P by Q, the answer can be, the quotient can be either terminating and can be either non-terminating, repeating or recurring decimals. So, by dividing P by Q, we will get either terminating and one is, other can be non-terminating, recurring. So, the decimal expression of a rational number can be terminating or non-terminating, recurring, repeating decimals. This section we will explore when the decimal expansion of P by Q is terminating and when it is not terminating, recurring. Now let's see few rational numbers. My first number is 0.375. This is a terminating decimal number. We can express 0.375 in the form of a fraction, which will be 375 by 1000. Here the numerator is 375 and denominator is 1000. If we divide 375 by 1000, we will get 0.375. If we prime factorize both the numerator and denominator, we can express these two as the product of the prime factors, which is 375 can be expressed as the product of 3 multiplied by 5 to the power of 3, and 1000 can be expressed as 2 to the power of 3 multiplied by 5 to the power of 3. So, by cutting the common, we can say 0.375, we can express this number in the form of 3 by 2 to the power of 3. Let's take another number, which is 0.0875. The same way, it is a terminating decimal number, and if we express that as a fraction, we can write it as 875 by 10,000. Prime factorizing both denominator and numerator, we can express that 875 can be expressed as 7 multiplied by 5 to the power of 3, and 10,000 can be expressed as 2 to the power of 4 and multiplied by 5 to the power of 4, which is equal to 7 by 2 to the power of 4 into 5. What we have seen here? Let's observe what we find here. See, what the both numbers which I have given is terminating decimals. What is the common in the denominator here? Here, the denominator is expressed as the product of the prime numbers 2 and 5. Here also, it is expressed as the product of 2 and 5. Here also, the prime factors are 2 and 5. Now, let's arrive into a theorem. The first theorem in the decimal expansion of rational number is, let x equal to p by q be a rational number such that the prime factorization of q is of the form 2 to the power of n multiplied by 5 to the power of m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. We have seen in the previous examples, the denominator q can be expressed as a product of the factors 2 and 5. So, we have seen any rational number p by q, where q is expressed as a product of the prime numbers 2 and 5, where the denominator can be expressed as a product of the prime numbers 2 and 5, 2 to the power of n and 5 to the power of n, where n and m are integers, positive integers. That numbers will have a terminating decimal. that numbers will have a terminating decimal. So, any number, rational number expressed in the form of P by Q, where Q can be, if we prime factorize Q, and Q can be expressed as the product of the prime factors 2 and 5. We need either 2 or 5 or can be both. The denominator Q can be expressed as a product of either 2, the prime factor 2, or can be 5 or can be 2 and 5 both. These numbers will have a terminating decimal. Now let's do another set of numbers. The first one is 1 by 7. If we simplify 1 by 7, we will get 0.1428571428. It never ends. It is non-terminating. And we can see it repeats also. Here 0.142857. Again it starts with 14285. It will repeat. So we can say that any rational number P by Q, where Q, the denominator, cannot be expressed as the product of the factors, prime factors 2 and 5. Here the denominator is number 7, which cannot be expressed as a product of 2 and 5. So such numbers will have a non-terminating recurring decimals. Such rational numbers will have, if we do the decimal expansion of such numbers, we will have a non-terminating recurring decimal. Now let's take one more number, which is 8 divided by 3. If we do the division 8 divided by 3, we will get 2.666666. It also never ends. So we can also say again the denominator here it is 3, which cannot be expressed as a factor, as a product of the factors 2 and 5. So any number, any rational number P by Q, where the denominator cannot be expressed as the product of the prime factors 2 and 5 will have a non-terminating, repeating or recurring decimals. The second theorem in the decimal expansion of rational number is, let x equal to P by Q be a rational number such that the prime factorization of Q is not of the form 2 to the power of n multiplied by 5 to the power of m, where n and m are non-negative integers. Then x has a decimal expansion which is non-terminating, repeating or recurring. I hope you are clear with the decimal expansion of rational numbers. We will do the exercise number 1.4 and 1.5 in my next video. Please do watch, like and share, and comment if you need more videos on the same topic. Thank you for watching.